Hello. In order to introduce vectors to you, I'd like to begin with a simple classification of objects in R. Perhaps the simplest classification is based on how many dimensions and whether the elements in the object have the same mode or different modes. The simplest form of variable is called a vector, and with vectors we've got a single linear dimension of elements, but all these elements have the same mode, such as here where they all are represented by numbers. In other cases they might all be represented by logicals, true or false, or by characters. The equivalent form when we have a two-dimensional collection of elements is called a matrix, and here in a matrix all of the elements have the same mode, typically in terms of numbers, but they can also be true, false, etc. When we've got a linear array of elements and those elements could potentially have different modes, then we have a list. So we can have character strings like bananas, true, false, and numbers. And perhaps the most versatile and general form is a two-dimensional collection of elements with different modes, and that is called a data frame. But let's go back to vectors. Vectors is an index list of elements, rather like a single drawer in a filing cabinet. All elements of the vector, as I've said, have to be the same mode. And we can refer to the ith element, where I is any number from 1 up to the number of elements it has, as a variable name, and then using square brackets for the I. So let's define a variable x like this. X is all of the elements from 10 to 18, and we use a colon to represent a simple sequence. Here we can move, of course, in steps which are less than 1 or greater than 1, in which case we would need an extra argument, but by default it's by 1. So when we ask what does x look like, well, we see this list of 10 to 18. That is a vector. What's the mean of those series of numbers? Well, we can call up tailor-made functions within R to ask that and simply say mean x, and we see the mean there is 14. Here are a variety of these tailor-made functions which are all default within R. We have mean, we have the variance, the sum, cumulative sum, median, and even length in terms of the number of elements in that vector. If we refer to the element of a particular vector, like x square brackets 3, then that implies we are asking for the third element in that vector, in which case the answer would be 12. So round brackets in this case contain the objects of functions like the sum or the mean, where square brackets refer to the index of that object, indicating what is the element value at that particular location. Let's see more about creating vectors. Let's say instead of a sequence we want to create 3 9 times. We can use the simple command rep, and for this we'll define p as rep 3, 9, and then we'll see 9 3's all laid out. What's the length of p? Well, length of p is 9. Now let's see this. You'll see here that I'm actually using round brackets around the overall assignment statement, where q is gets rep true, 3. By putting the brackets all the way around, I don't have to have that second step of saying what is q. It will actually print out to the console what q actually is. So when we say something like this, what we're seeing is true 3 times. But we're defining true here as a bunch of characters, TRUE, rather than a logical. And the way we've done that is put it in inverted commas. What's the mode of Q? Well, the mode of Q is character, so it's a vector made up of characters. But here we could say R is rep true where we're not using inverted commas, and what we would get here printed out is true, true, true. But you'll notice that it's not in those quotes. The mode of R is a logical mode. So I did say that we can count in steps other than one. We can use sec for that. We can define those arguments by name. We can say from, to, and by. But if we simply said 192, that would be fine because it takes from the very first, the second one is to, and the third argument in that function is the by. So that's what we would get there, 13579. Now here what we could do is sec 11, 23, 3, so we've missed the names of those arguments, and you'll see here that's what we get. Concatenate is a very important operator in R because it adds new elements. So we can say X is defined by 2.2, 3.1, and 1.7, and we've concatenated all of them. So we're combining them all into a single vector. And this is what we get when we say that. And of course the round brackets around the side get the console to print the value of X. So X doesn't have a single value, I should say that it has three separate elements as the way we have defined it. So let's play some more with vectors. Let's define the vector W as a collection of numbers using the concatenate function. If we ask then what W square brackets 3 is, we're asking what the third element of that vector W is, and in this case it's 3.2. We can write code all on the single line if we use a semicolon. So we can ask what's the size of the minimum element in W and what's the maximum size of the elements in W, and in this case we get 2.1 and 5.2. We can ask R to sort that vector. The default is from the smallest to the lowest, and this is what we get here. Now, if we want to combine our vector in a way such that we want W, but we want to duplicate it, and so we get two sets of W's put on, we can use the rep function, and the argument is times equals 2, and we will create two sets of those vectors all nicely combined. But if we wanted to do this element for element instead of combining them neatly like the previous, then what we would use is the each argument of the rep function, and in this case what we would have is each of them replicated twice, so each element 3.1 and 3.1 and then 2.1 and 2.1 are repeated. Now let's have a look at this, where we're combining one vector with some extra numbers, and here Q is defined as the concatenate between the vector W and 2.3. Then Q is W, and yet it's got 2.3 tacked on in the end. What's the length of Q? Well, it's one up. It's gone up to 5 elements now. Let's have a look at how we combine vectors. Here A is defined as the collection of numbers between 1 and 4. B is likewise defined as 5 to 8. Then we can ask what A plus B is, and we can simply get the answer 6, 8, 9, and 12, 10 and 12, because we're simply adding up the element for element combinations. What would happen if we try and combine one size of a vector with another? Clearly there will be elements left over, and I'll leave it to you to find out what R does about that. In effect, it throws up an error message. Let's continue with concatenate. Let's define F as a list between 100 and 105. It's a nice, a neat array. And the important thing to note here is the index itself of a vector can itself be a vector. So for example, if I is 1 to 3, then F square brackets I are the first three elements, 100, 101, and 102. Thank you for listening to this R Labs tutorial video. If you found this useful, you might be interested in our free online Moodle course, or check out and subscribe to our YouTube channel.